Now this topic might seem very basic and simple, and what's the point of a video on it? But over 80% of the students I work with either don't know how to work this out or can't do it correctly. So what am I talking about? How do we find the distance between 2 points? This topic comes up all the time in the real GRE exam, as well as the GMAT exam and hundreds of other quantitative exams. So it really pays if you can do this confidently and quickly. Let's get straight to a question. What is the distance between the coordinates 5, 0 and 0, 6? You can pause the video and try and work this out yourself, but for those of you who are not confident that you're able to work this out quickly and correctly, I'm going to show you the trick. So what is that trick? You think of those two coordinates as being the hypotenuse of a triangle. So you imagine the two coordinates we've got are the long side of a triangle. Our job, therefore, will be to find the horizontal distance between the two coordinates and then the vertical distance between the two coordinates. And can you guess what we're going to do when we find those two distances? If you guessed Pythagoras, give yourself a golden star. After we find the horizontal distance between the two coordinates and the vertical distance, we can then apply the Pythagorean formula. A squared plus b squared equals c squared. And that c squared, that hypotenuse squared, will give us the actual distance between the two coordinates. So how does that work in practice? Let's get back to that question of what is the actual distance between the coordinates 5, 0 and 0, 6. Can you first tell me the horizontal distance between those coordinates? I'll give you a hint. You need to find the difference in the x coordinates. The x coordinates are the first of the two sets of numbers. So the coordinate 5, 0 means 5 across on the x-axis and 0 up on the y-axis. So the 5 is the x coordinate. For the coordinate 0, 6, that means 0 across on the x-axis and 6 up. So 0 is our x-coordinate. So what is the difference between those two x-coordinates of 5 and 0? 5 take away 0 is of course 5. So the horizontal distance between those 2 points is of length 5. Doesn't matter about the units. Now, what's the vertical distance between those two coordinates? The hint here is we need to find the difference in the y coordinates, which is the second of the two numbers. 5, 0 had a y coordinate of 0, while 0, 6 had a y coordinate of 6. 0 take away 6 is minus 6. Notice how I always started the calculation with the numbers from that first coordinate, 5, 0, and then took away the numbers from the second coordinate, 0, 6. You have to stay consistent with which coordinate is your first set and which coordinate is the set you're going to minus from. So the vertical distance is minus 6, but we don't care about that sign. We just care about the actual number, 6. The minus just indicates it's 6 below, but we don't care about the direction. We just want to focus on the number 6. So ignore the minus, that distance is 6. So we have a horizontal distance of 5 and a vertical distance of 6. How can we use the Pythagorean formula? Well, those two coordinates would be our A and our B. Don't forget, in Pythagoras, the A and B represent the two shorter sides, the horizontal and vertical, while the C is that hypotenuse, the longer side. It doesn't matter which one's which in terms of the horizontal or vertical, but the 5 and the 6 are going to be our A and our B. Putting that into the formula, very carefully, we can work out our C. And I say very carefully because many students make a mistake at this point with the C squared and they forget to square root. So let's pay attention here. If the 5 could be our A and the 6 is our B, we have 5 squared plus 6 squared equals C squared. And I strongly recommend you write out that equals C squared. Many students neglect to do so and they start making mistakes later on because they forget to square root. 5 squared is 25 and 6 squared is 36. And adding together 25 and 36, we would get 61, I believe. So 61 equals c squared. Remember to write that equals c squared. Now, if 61 equals c squared, what does c equal? What is that magical hypotenuse? C would be the square root of 61. We don't want to know what c squared is, we want to know what c is, so we have to square root both sides. Now in the GRE, of course, we have a calculator, so we just work out the square root of 61 as an actual number. In the GMAT, we could just leave it as square root 61. That is our hypotenuse, and therefore that is the actual distance between those two coordinates, root 61, roughly 7.8 or 9 or so. If you're liking the trick already, please leave a like or a comment or a question, and please do subscribe. But for those of you who really want to solidify this, I'm going to give you a harder example now, and then I'm going to finish with a wordy example. Everyone's favorite. Here's the harder example. Pause the video and have a go at this if you can. What's the distance between the coordinates -2, 4 and 3 and 16? Okay, first we find the horizontal distance. That's the distance between the x coordinates. -2, take away 3, those are the two x coordinates. -2, take away 3 is -5. But we don't care about the negative sign, so that distance is simply 5. 4 minus 16 is -12. But again, we don't care about the negative, so the vertical distance is 12. Putting that into the full Pythagorean formula, we have 5 squared plus 12 squared equals c squared. Some of you might be familiar with this as a Pythagorean triple, but that will be for another video. For the rest of you, let's work it out. 5 squared is 25 and 12 squared is 144. 25 plus 144 is 169. And did you remember to write 169 equals c squared? I really emphasize that because it helps us remember to square root. Too many students forget to square root. If 169 equals c squared, square rooting both sides, you kind of should know this one off by heart. Square root of 169? 13. So c equals 13. The distance between those coordinates is 13. Final example, this time a wordy one. Saurabh and Hassan start at the same location. Saurabh travels 5 miles east and then 5 miles north. Hassan travels 2 miles west and then 7 miles south. What is the distance between Saurabh and Hassan now? It's a trickier one because I haven't given it to you as a coordinate, I've given it to you in terms of words. But can you work out the two coordinates? Saurabh would be at 5, 5, whereas Hassan would be at -2, -7. We can now apply our amazing knowledge. What's the difference between 5 and -2? We've got to be super careful though, because it's easy to make mistakes. Let's take that coordinate 5, 5, and we're going to minus it from the other coordinate -2, -7. We've got to be so careful here because of the double negatives. What is the difference between 5 and -2? That's the horizontal distance. Hopefully you got 7, because 5 take away -2, that double negative cancels out and becomes a plus. 5 plus 2 is 7. If that doesn't make sense, draw it out visually and see if you can spot that the horizontal distance between those two coordinates would indeed be 7. What's the difference in the y coordinates? Well, 5 take away -7 again becomes a plus, and 5 plus 7 is 12. Popping those two results into our formula, we have 7 squared plus 12 squared equals c squared. 7 squared is 49, 12 squared is 144. Let's see if I can do this in my head. 144 plus 49 is 193. Let's go with that. 193 equals c squared. And of course, we can now square root both sides to find c. On the GMAT, we could leave it as root 193. On the GRE, they might expect you to use the calculator. Doing this in my head, that's roughly 13.9. And that is the distance in miles between Saurabh and Hassan now. Really hope you enjoyed that trick and learned that trick. It comes up all the time in these tests. So if you did, leave a like, leave a comment, and of course, subscribe, and have a great day.